Now we're going to be deriving the formula for finding the gradient of a tangent. Okay, now I just want you to look at this graph here, and I will try to analyze it with you. Now you realize that in this graph, it's a black graph. Obviously, it's a graph with a black line. There are a couple of lines passing through that line. Okay, firstly, it's the red line. Look at the red line. Do you realize that the red line is actually touching the graph twice? It is touching the graph at this point and at that point. Now I need you to understand that at this point here, x is the x value is just x, and the y value is f of x. All right, at this point here, the x value is x plus h, and the y value will be, actually it's at that point, the value will be f of x plus h. Okay, now what I want you to understand is that the difference, the x value actually increased by h. Okay, because this value will be x plus h, so the distance from here up to there will be h. All right, similarly here we don't know what the y value is, so our y value in this case, the difference in our y value will be basically the distance between f of x plus h and f of x will be f of x plus h minus f of x, and the difference between our x values will just be h, of which you take this x plus h and then you minus x, you'll be left with h. So the distance from here to there will just be h. Now here is what calculus says. Calculus says if this distance here, if the x distance decreases, meaning that if h keeps on being smaller and smaller and smaller until it becomes 0, meaning that as h approaches 0, we are getting closer and closer to finding the gradient of the line at a certain point, at one point of the graph. Okay, we're simply trying to find the gradient of a tangent line at a specific point on the original graph. So as h gets smaller and smaller, we also get closer and closer to getting the gradient of the tangent line at a specific point on the graph. Okay, so basically in this case, as h approaches 0, we're getting closer and closer to finding the gradient, and this is what gave birth to a formula that allows us to find the gradient of a graph. This is just theoretical. You will do this later on when you do calculus at varsity, if you do chartered accountancy, or if you do engineering, or whatever you want to do, immediately when you do maths, because in accounting there's maths, there's calculus, and we had to do this. So you will actually do this in first year, and you'll get to understand it better in first year. For now, I don't want to confuse you with this, but I'm just giving you an idea of what calculus is. So basically, we are simply trying, in this scenario, we are simply trying to find the gradient of a tangent at a specific point on the graph. Please note that we are dealing with a parabola. The graph that we're given here is a parabola, and it becomes very difficult for us to find a gradient. It's easy for you to find a gradient of a straight line, but with finding the gradient of a parabola, you have to use this formula. Okay, now we call it the principle. Okay, the first principle. H is the difference between the x value and the next resulting value in a different y value. All right, now the principle is that as this difference between x values gets smaller and smaller, the line ends up touching the curve only once, and hence becoming the tangent to the graph. From this sentence, we can conclude that for us to find the tangent is simply a straight line that touches a graph only at one point. All right. Now, the first principle, and which is what I'm going to be introducing later on, it allows us to find the equation of the gradient, actually, of the tangent at a specific point of the graph. Now, remember, when you found the gradient, you will simply take ya minus yb over xa minus xb. This is actually very important because this is what gave birth to the first principle. And hence we have this here. I did show you this earlier on, where we have the y value, the highest y value. If you still remember very well, when I found the difference between the y values, I had f of x into h minus f of x. All right, so basically this is the difference between the y values. So basically what I did is I'm going to use random numbers here. Took 1, if this is y1 and y1 is equal to that, and this is y2 and y2 is equals to that, I'll have the gradient the gradient is simply, for you to find the gradient of a straight line, you'll have y1 minus y2 divided by x1 minus x2. In this case, our y1 is and this is our y2. It will be divided by and then you'll realize that the x's cancel out. Now, this can only be the gradient of a tangent if h gets smaller and smaller, so close, so small that it gets close to 0. This is the only time that this will be a gradient. That's why instead of finding just the average gradient, we had to include the limit. It's limited, so the gradient of a tangent is only limited only if h approaches 0. Okay. Hence, we have this equation over here. Now, please note, we normally refer to this as f prime x. Please note that f prime x is actually the gradient of a tangent to the graph. F prime x is just the gradient of a tangent to the graph, okay? Where f prime x is the gradient to the tangent at the graph. Basically, in this point, it will be at where x is x and the y value will be f of x. H is the change in x, and this change approaches 0. I did explain that. F of h plus f of x plus h is the corresponding y value of the increased x value. Okay, this y coordinate will approach f of x as h approaches 0. I'm just going to explain that just now. So basically what this says is that as x gets smaller and smaller, so to the extent that it approaches, as h gets smaller and smaller, to the extent that it approaches the x value or it approaches 0, meaning that this difference in x values gets closer to x, the y values will also decrease. to the extent that they get closer to f of x. As I've said, if this is a little bit difficult for you, don't stress yourself about it. You will understand it later when you go to varsity. Now, this formula is what we refer to as the first principle. So basically, we're going to use this formula to calculate the gradient of a tangent to the graph at any specific point. It must be at a specific point. I'm going to pass the limits part, okay? And I'm going to get straight into this. We're going to be doing number 1, 2, and then you will do the rest.